Section 6.6, trapezoids and kites. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. Things to keep in mind are the terms bases, which refer to the parallel sides of the trapezoid, legs, which are the non-parallel sides, and then base angles, which are the two angles or any two angles in the trapezoid that share a common base. And so if we look at this diagram, we have an illustration of what each of these items would be. We've got bases on the top and the bottom of this shape here. They happen to be parallel, that's indicated by the markings. We have our legs, which are our non-parallel sides. And then our base angles, we have a base angle here, and a base angle here, and then we have a pair of base angles here and here. An isosceles trapezoid is a trapezoid with two legs that are congruent. Just like an isosceles triangle, an isosceles trapezoid has two congruent legs. So our first theorem says that if a quadrilateral is an isosceles trapezoid, then each pair of its base angles are congruent. So just like the isosceles triangle, if it's isosceles, you know that the base angles will be congruent. In this case, trapezoids, however, have two sets of base angles. So if you have an isosceles trapezoid, there'll be two sets of congruent base angles. There'll be two at the top that are congruent and two at the bottom that are congruent. CDEF is an isosceles trapezoid, and angle C has a measure of 65. What are the measures of angles D, E, and F? Well, right off the bat, they told us it's isosceles, so we know that these segments are equal here. But what we know more importantly is that we're going to have congruent base angles. So this angle at 65 here should be congruent to this angle here. So that right off the bat, we know that the measure of angle F is 65. The other thing we know is that these are parallel sides. So these two angles here would be same side interior. So they're supplementary. So to find the measure of angle D, all we need to do is subtract 65 from 180. So in that case, angle D should be 115. And angle D and E are base angles of the isosceles trapezoid, so that means angle E is also 115. Question 2. In the diagram, PQRS is an isosceles trapezoid, and the measure of angle R is 106. What are angle P, Q, and S? Well, we approach this the same way we did the last one. So see if you can figure this one out. Pause the video, figure it out, and then unpause it to check your answers. So in this case, we know that the measure of angle R and S should be the same because they're base angles. So that means angle S is 106. We also know that angle Q and R should be supplementary because they're same side. So we take 180 minus 106, we get angle Q to be 74. Angle P and Q are congruent, so that means angle P is also 74. If a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So isosceles trapezoids have congruent diagonals. Here we run into the trapezoid mid-segment theorem. It says if a quadrilateral is a trapezoid, then the mid-segment is parallel to the bases. And mid-segment just means the segment connecting the midpoints of the two legs. The length of the mid-segment is half the sum of the lengths of the bases. Okay, so basically if we have a trapezoid and with a mid-segment or a segment that connects the midpoint of the two legs, we know that the mid-segment is going to be parallel to both of the bases. But more importantly, we know that the mid-segment is equal to 1/2 the sum of both of the bases. So this is important. We want to keep track of this because we're going to use this in the next few slides. So here, QR is the midsegment of trapezoid LP and M. we want to find the value of x. Well, we know that the mid-segment, in this case QR, should be equal to half the sum of the two bases, so LM plus PN. So now all we need to do is replace the names with what they actually equal. So QR is x plus 2 equals 1/2. Here we have 4x. Oop, that should be minus 10. 4x minus 10. So we have minus 10 there. And then we've got plus 8 for PN. And so now we just want to solve this. Well, first thing we're going to do is we're going to go ahead and simplify what's in parentheses here. This is 4x minus 2 times 1/2 equals x plus 2. We can multiply both sides by 2 to get rid of the 1/2 or just distribute it. I'm going to go ahead and distribute it. So I've got x plus 2 equals 2x minus 1. Then I'm going to solve this. So I'll subtract x to the other side. At the same time, I'm going to add 1 to the opposite side. And I've got 3 equals x, so x equals 3. Question 2. MN is the midsegment of trapezoid QPSR. What is x and what is the length of MN? So once again, MN is our midsegment, so it's equal to 1/2 the sum of the two bases, so QR plus PS. And so we just replace the names with what they equal. So MN is 2x plus 11 equals 1/2 10 plus 8x minus 12. We'll clean up what's inside the parentheses here. So that's 8x minus 2. So 2x plus 11 equals 1/2 times 8x minus 2. This time I'm not going to distribute the 1/2. Instead, I'll try a different method. I'll just multiply the entire problem by 2 so it cancels out the 1/2 on the right. So that means I have to double what's on the left. So this becomes 4x plus 22 equals, that cancels with that, so I've got 8x minus 2. So in this case, I'm then going to go ahead and subtract 4x to the other side. I'll add 2 at the same time. So now I've got 4x equals 24. And if I divide by 4, I'm going to get x to equal 6. To find the length of MN, I'm just going to plug it back in. So 2 times 6 would be 12. 12 plus 11 gives me 23. So the midsegment is 23. A kite is a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent. So in a kite, you have consecutive sides. So this side is consecutive to this side, and they're congruent. And this side is consecutive to this side, and they're congruent. If a quadrilateral is a kite, then its diagonals are perpendicular. So the diagonals of a kite form right angles when they meet. So here, in question 1, quadrilateral DEFG is a kite. What are the measures of angles 1, 2, and 3? Well, angle 1 should be very easy to find. If it's a kite, we know that the diagonals are perpendicular, so that means we're making right angles in the middle here. So angle 1 is 90 degrees. To find the measure of angle 2, we're going to take 180, or the measure of an entire triangle, and we're going to subtract the two angles we know. We know angle 1 is 90, we know this one is 52, and so whatever's left over will be the measure of angle 2. So we're going to take 180 minus 90 minus 52, and in this case we get angle 2 to be equal to 38 degrees. All right, and then the last measurement we have to find is angle 3. But what we should remember is a kite has consecutive sides congruent. So in that case, this side is congruent to this side, essentially making this upper piece here an isosceles triangle. So this base angle is congruent to this base angle here, meaning that angle 2, which is 38, is here and here. So that means the only possible measurement for the measure of angle 3 is for it to also be 52 degrees like the angle right beside it. Essentially what we have up top here are two congruent smaller triangles. All right, question 2. Quadrilateral KLMN is a kite. What are the measures of angle 1, 2, and 3? All right, so similarly, angle 1 is really easy to find. We know that the diagonals of a kite are perpendicular, so angle 1 is 90. We also know that the right angle would be here as well. So to find the measure of angle 2, we're going to take 180 minus 90 minus, well, we don't know what the other angle would be, but remember, we kind of do, because if these sides are congruent, this angle here is congruent to this angle here. So angle 2 is the same on both sides of the triangle. So that means angle 3 must be 36. So angle 3 is 36. So to find angle 2, like I was saying, we're going to take 180 minus 90 minus 36, and that's going to give us the measure of angle 2 to be 54 degrees. Question 3, find the values of the variables in each kite. So we're looking for the value of x. Well, there are a couple of ways to find x, but I'm going to take you what I think is the easiest way. Let's just focus on this particular triangle here. Remember, the diagonals of a kite are perpendicular, so there is a right angle here. And so what we know now are the three measurements that make up this triangle. So we can take those and set those equal to 180 to solve for x. We'll go ahead and simplify things down. We've got 6x plus 96 equals 180. We're going to go ahead and subtract 96 from both sides. We've got 84 equals 6x. We'll divide by 6, and we're going to get x to equal 14. Question 4, what are the values of the variables in each kite? So once again, we're looking for the values of the variables, and this time there's two variables. But to find x, we're going to do the same thing we did in the last problem. We're going to, in this case, take 180 and set equal to all of the pieces of the right triangle here, or the triangle on the right that we have. So 38 plus 17x plus 1 plus 3x plus 1. Let's clean this up. We've got 20x plus 40 equals 180. We'll subtract 40 for both sides. We get 140 equals 20x. Divide by 20. X should equal 7. So now what we know in order to find the value of y is, if we look carefully back at our diagram, we should notice something special about the two halves of this kite. In this case, it creates two congruent triangles. They already have matching sides here, and then here, and here, but then through the reflexive property, this side is also congruent to itself. So what we should know is that this angle here is equal to this angle here by CPCT. So what we need to do first is plug in x here, so that we can figure out what this angle's true measure is. So 7 times 17 plus 1 would give us 120. So this angle has a measure of 120. So what we can do now is take 2y and set it equal to 120. When we solve this, we get y to equal 60 degrees, or just 60. All right, so y is 60, x is 7. Find the values of the missing angles in the kite. So one of the things we can do is we could draw the diagonal here, splitting this kite in half, which then tells us that we now have two congruent triangles, so we are able to set this angle here equal to this angle here through CPCT. So that means the measure of angle 1 is equal to 110. Once we know what angle 1 is equal, we can now start looking at the shape as a whole. We know that a quadrilateral has an angle sum of 360. So we're going to take 360 minus all of the other angles to figure out what we're left with to be angle 2. So 360 minus 110 minus 110 minus 98 is going to give us a total of 42 degrees. So that means the measure of angle 2 is just 42 degrees.